Good afternoon.
Good morning.
Hello. Can you still hear me?
Yep.
Yes.
Can you see me?
Yep.
Yes.
All right, I can't see you guys yet. Let's see if everything got turned off. Oh, there you are. All right, so let there be light. Is that better? Let's see now. How about that? Okay. Now, where is, let's see. Okay. All right. Well, so did anybody do anything amazing over the holiday?
I went to the lake.
The lake, and what did you do at the lake?
Surfed and wakeboarded.
No, that sounds pretty fun. That sounds pretty awesome. Anybody else do anything amazing?
I went out shooting with my brother.
Okay. What were you shooting?
I don't even know. Whatever gun he brought.
All right.
Nathan went to Florida.
Florida?
Yeah, I went to Florida, and I didn't die in Hurricane Dorian, so, pretty proud of myself.
So I'm surprised you. When did you fly back?
I flew back Sunday, I believe.
So was the airport just crazy?
No, because I flew out of South Dakota. It's a weird story. So I just moved here from South Dakota, and so I spent a little time in South Dakota after Florida, and I flew in from there, so it wasn't that bad.
Okay. All right. Well, you guys keep. Let me call a roll real quick, and then you can be thinking if you did anything amazing. All right, Joran.
Yard goats.
Here.
Rachel.
Here.
Alana.
Here.
Nathan.
Here.
David.
Here.
Chloe. Let's see, Chloe told me she's going to be absent today. Aiden.
Here.
Brett.
Here.
Denon.
Here.
Matthew. Oh, we thought Matthew dropped, maybe? Skylar.
Here.
Hannah Whipple.
Here.
Here.
Brooke. Joseph.
Here.
And Hannah Zent.
Here.
Here.
Okay, so did anybody else think of anything amazing they did? Here, I'm going to plug this in. Let's see, so have any of you seen the movie Courageous, or no, what's it called? Overcomer. Anybody see that? Well, the hero is a 15-year-old girl. And anyway, it's a very inspirational movie. If you like that kind, I thought it was very, very well done. So, The Overcomer. Let's see.
Mr. Strong,
Yes, sir.
did you do anything amazing over the weekend?
Well, seeing that movie, I took my wife to like a resort on Friday, and then we saw that movie, and we had like the best Mexican food ever. And it's the 4-day weekend had so much promise, and then I got sick. And so 3 of the 4 days, I was pretty miserable. So, matter of fact, I told my wife, I said, if we didn't have Monday off, I probably would have had to call in sick. That's how bad it was. And that really takes a lot. So it wasn't all that amazing to me, but, But I was glad to at least, I'm glad I didn't have to miss a day anyway. So, but heading to the resort, that was fun. The Mexican place was in Cottonwood called Conchos. And anyway, it was just amazing. It was amazing. So that was the highlight for me. Kind of went downhill quickly though. I don't know if any of you have ever had migraines, but I get them like twice a year that are just crippling, and it's just awful. So I hope you never get that. So anybody else think of something fun they did before we get started?
I went to my niece's baby blessing
Where
in
was
the
that
valley.
at?
In the valley.
Okay, well that's cool.
I made pizza.
You what?
That's
Made
fine.
pizza.
You made homemade? All right. Well, did anybody else eat it or just you?
My family and a couple friends.
Okay, just pretty much loved
Yeah.
ones though, right? That didn't want to, they want to support you, right? So that's good. That's good. Well, my wife makes amazing pizza, so I'm glad. She told me that if you know how to make pizza, let's see, what did she say? If you know how to make pizza, and you know how to cut hair, you'll never want for a date in college. So I'm like, so how does that work? And so she said, well, just, cut hair, and then the guy takes you out, or invite people over for pizza, bring your own toppings or something. So anyway, I don't know. I didn't know how to do either of those things. But all right, well, let's go on to, let's get back to our lesson here. We're on 1.3, and we are in the middle of our trig review. Okay. So we were, I wanted to just have you maybe write this down just because, so just somewhere in like the margins there on 1.3, so you could have this. This is kind of where the trig functions are positive. And so in the first quadrant, all of the, we're talking about just sine, cosine, and tangent. And so all of them are positive there. And then in quadrant 2, we have just the sine of sine, cosine, and tangent. The sine is positive. And then in quadrant 3, the tangent is positive. And then in quadrant 4, the cosine is positive. And so, anybody remember from trig the little mnemonic device to help you remember that?
It was
Awesome students take calculus.
And here you are. And was that not a self-fulfilling prophecy? Yes, it is. So you guys are awesome. Awesome students take calculus. So starting in quadrant 1. And so that just helps you kind of remember. Okay. Let's see. Degrees, minutes, seconds. Again, this is not necessarily on your sheet, but as we were talking about things, really what this is that as people have asked me different trig things over the years, I thought, well, let's just remember, just put up some things to remember. So this is a slide from trig that 1 minute is 1/60th of a degree, or 60 minutes is 1 degree. And then 1 second is 1/60th of a minute, or 1/3600th of a degree. Now, having said that, really in calculus, we don't use degrees, minutes, and seconds all that much. because most of the calculus formulas are assumed that you're in radians, okay? But for application problems, you might see one where you have to do degrees, minutes, seconds. Okay. All right. So most applications use degrees. Okay. All right. So, okay. So let's say that we want to. Okay, so this isn't exactly working right for us, but that's okay. All right. So, how would we, if so, this is just an application problem. If we walk back 40 feet from the base of a tree, and you can use actually a protractor and a straw to kind of measure the angle to the top of the tree, and let's say you measure it 61 degrees, 55 minutes, 39 seconds. How tall is the tree? How could you do that using trigonometry? So you don't have to calculate it. We're just talking here.
You could like use tangent.
Okay, why tangent?
Because the side you're looking for is the opposite, and the side you know is the adjacent.
Excellent. So that's exactly what you do. Is you say, all right, so from this angle, the side you're looking for is the opposite side, and then you know the adjacent side. And so then you say, well, what trig function relates opposite and adjacent? That would be tangent. Okay? And then you would then come up with the equation. Let's see here. So then you would say the tangent of the angle is opposite over adjacent, x over 40. And so then to solve for x, you would take 40 times the tangent of that angle. Okay? All right, so let's see if you remember how to put that in your calculator. So we want you to put in 40 times the tangent of 61 degrees, 55 minutes, 39 seconds. So see if you can remember how to put that in. If you don't worry about it, but let's see. Okay, so let's so anybody have it? All right. So St. John's, tell us, Aiden.
Yeah, it's like 74.999. Yeah.
So approximately 75 feet tall. So you get 74.999 or something like that.
Yeah.
So about 75 feet tall. Is there anybody having any trouble keying that in that wants me to go through the keystrokes? I'm just curious. Okay. All right. So, all right. So let's. Okay. So the way you key it in is you first of all when you're putting in a trig function of an angle measured in degrees, you need to make sure you're in degree mode. Okay, so mode, and we're in degree mode, so that's cool. All right, then you just type in 40 tangent, and then 61 degrees, so 6, 1. And so the degrees is in the angle menu, so second angle, degrees. 55 minutes, so also in the angle menu. So second angle, the second option is minutes. And 39 seconds. Now, the seconds are not in the angle menu, but instead they're in the alpha keys because they're quotation marks, which we use a lot with the alpha keys. So alpha plus gives you the double tick marks, and then you press enter, and boom. So that would be rounded to 75. Okay. All right. Any questions on that? Oops. Okay. All right. Let's see. Practice. Okay. Okay, let's see here. All right. Let's see, then these are the graphs of the 6 trig functions. This is basically how they look. Okay. I was wondering what's going on here. Let's see. Hold on just a second. Okay, was this is this problem on your paper? Practice 5?
Yes, except for
Okay.
it doesn't have 16-foot ladder. It doesn't give us the height of the ladder.
Okay. Let's see. Oh, so it doesn't say 16-foot ladder?
It just says a brand of ladder.
Okay. Let's go ahead and write that in, 16 foot. And maybe that's why I've taken it out, because I was going to change that. And yeah, go ahead and try that one. All right, so Alana, when you've got it.
4.14.
12.14. Okay. It's going to be 4.14. Is that what you said?
I said, yeah, that's what I said.
Okay, I'm sorry, I misheard you. Yeah, it's 4.14. Good. Okay, so in this case, you're going to use the cosine because you know the adjacent, or you're looking for the adjacent, and the 16 feet of the ladder is the hypotenuse. So that's why you use cosine. So 4.14, 1 feet. All right? So good job. Any questions on that? Anyone not get 4.14? Doesn't see why it's that.
We're good.
Okay. All right. All right, next. These are the basic graphs of the trig functions. So now you don't have to memorize these or anything because you can put them in your calculator easy enough. But again, when you're graphing, make sure you're in radian mode. Okay, but I just want to point out a couple of things here. First of all, notice that sine and cosine look an awful lot alike. You know, the basic wave. The way that you keep them apart, you tell them apart, is that the sine goes through the origin and the cosine goes through the point 0, 1. Okay? Now they both go from -1 to +1, and they have a period of 2 pi. All right, secant and cosecant also look very similar. And the easiest way to produce these graphs by hand is by graphing the inverse function first. So like if you're wanting secant, then you graph the cosine. And then you do the little U shapes from the graph of the cosine. So like here the cosine is going to come down. And so everywhere there's like a hilltop on the cosine, the secant goes and just touches that. And everywhere there's, you know, the valley of the cosine is sort of where the U shape reaches that. Same thing with the cosecant, you graph the sine. Okay, again, the sine goes through the origin. So you just imagine the wave going here. And then everywhere the sine is 0, that's where you're going to have your vertical asymptotes. And then that you form the little U shapes between the vertical asymptotes. Then the last two are the tangent and the cotangent. And so you graph your vertical asymptotes where the denominator of each is 0. So for tangent, you look at where the cosine is 0. So that would be at pi halves, 3 pi halves. And then once you graph those asymptotes, then the tangent from left to right goes up. It goes up, goes up. Whereas the cotangent, you say, okay, cotangent is cosine over sine. So whereas the sine 0, and that would be at 0 and pi and 2 pi, all the multiples of pi, and then you draw the cotangent going down from left to right. Okay? Now, I'm not trying to, like I said, my expectation here is that you just understand the basic look. You don't have to feel like you have to memorize these because you can just throw them into the calculator and graph them. Okay? Now, when you are graphing them, what I would suggest you do is do zoom trig. Zoom trig sets your window to go from -2 pi to +2 pi. So just pick one of the trig functions and then just graph it and then do zoom trig so that you can kind of see how that it looks similar to what we're doing. All right. Any questions on that? Anybody have any trouble graphing trig function or the zoom trig? Okay. All right, now on the sheet, on the guided notes, you'll see, let's see, actually it's at the bottom of the next page. Well, let's see, where is it? Two special triangles. Where is that at? Here we go. Why can't I see that? Two special triangles. So the two special triangles that I want you to draw are the 30-60-90 triangle and the 45-45-90 triangle. Remember, we're trying to make this like a resource for you. Okay? So now what I would like you to do after you draw those two triangles is label the sides and the angles as best as you remember them. And then we'll go over it. All right, so just sort of double check, see how you did. So the 45-45-90 in radians is pi halves, pi halves, pi fourths, pi fourths, pi halves. And the ratio is 1, 1, radical 2 for the sides. So if this is like 10, 10, 10 radical 2, or 5, 5, 5 radical 2. The 30-60-90 triangle in radians is pi 6, pi thirds, pi halves. And then its ratios are 1, 2, radical 3. Or like 10, 20, 10 radical 3. So on. Or 2 is the hypotenuse there. Okay. All right, now, okay, a lot of the rest of this sheet are formulas. Now, what I would like you to do for tomorrow, really, is to kind of finish out this sheet using the formulas from your book, okay? So the Pythagorean identities, let's see if, so to start copying, going through there, so this is 1.3, and the Pythagorean identities are going to start here. Let's see here. So page 24 at the very bottom, you're going to see the Pythagorean identities. All right, then the addition formulas, double angle formulas, half angle formulas, the law of cosine. So that's all on page 25. So what I'm wanting you to do is just write down all these formulas so that they're all there on your paper. Okay? Then we have the law of sines. Okay, so the law of sines is not on in your book, but it should be. So let's make sure that we've got the law of sines. Okay, so the law of sines is that the sine of angle A over side A is equal to the sine of angle B over side B. So add that into the law of sines. Okay, then the two special identities, going back to your guided notes. So those are on page 26. And I'm going to go ahead and pop those up because I just want to talk about that. So these two special identities, you actually didn't do these in trig, okay? These are identities that we will use later with limits. Okay, so I'm kind of foreshadowing to what we're going to be doing in the next chapter. So you're going to want to have these on your trig sheet, but this part is not review. That's new. All right, so now, okay, so then transformations on sine and cosine. Let's talk about that. Okay, so when you have sine and cosine, let's look at the this example here in red. So you have the number in front, and then this on the paper I have, it could be either function, sine or cosine. So we have a sine bx plus c plus d. So the number in front is the absolute value of that number is called the amplitude. And so that tells you the height of your sine or cosine wave. And so since height can't be negative, it's the absolute value. So if the number in front is like -7, the amplitude is +7. And that means that the wave goes up to +7 and down to -7. It's just if it's negative, it goes down first. Whereas most of them go up first if they're positive. Okay, the period for sine and cosine is 2 pi divided by b. So the number in front of the x affects the period. All right, the c and the b determine the horizontal or phase shift. So it goes the opposite direction, just like when we did regular functions. And so it's c divided by b. And then finally, the d, the number on the outside, is the vertical shift. All right? So let's put all of this together here. I guess, I said 2 pi divided by b. That's going to be the period of sine, cosine, cosecant, and secant. Tangent and cotangent, their normal period is pi divided by b. Okay? So tangent and cotangent have a smaller period than the other 4. All right, so here's an example. And what we want to do is determine the amplitude, the period, the horizontal shift, and the vertical shift. Okay? So the number in front determines the amplitude. So here the absolute value of 3 is 3. So the amplitude is 3. All right, the period is 2 pi divided by b. So here it's 2 pi divided by 2, or pi. The period is pi. The horizontal shift is 4 divided by 2, which is 2 to the right. Why to the right? Because it's negative in there. So it kind of goes the opposite direction. The vertical shift is down 1. Now, other things that you might be asked based on this information is what's the max and the minimum of the graphs. Okay? Now, this is kind of how you look at the amplitude and you look at the vertical shift. See, normally with an amplitude of 3, the highest point would be 3 and the lowest point would be -3. But then this is shifted down 1. And so our highest point of 3 is moved down to 2. And so our maximum point is 2. Our minimum point would be -3, but it's shifted down 1. So now our minimum point is -4. Okay? So any questions on how we got any of that? Before I have you do one. Okay, so let's see if you got it here. All right, so here's your function. So I want you to find the amplitude, period, horizontal shift, vertical shift, maximum, and minimum. All right, Denon, what's the amplitude?
3.
3. All right, Rhett, what is the period?
Pi.
Pi. So it's 2 pi divided by 2, so that's pi. All right, Skylar, what is the horizontal shift?
Left a half.
Left pi halves. Because the c here is pi. So it would be pi, c over b. So pi over 2. So negative pi halves or pi halves to the left. Okay? So the c is pi. All right, any questions on that? Okay. All right, so Skylar, what is the vertical shift?
Down 4.
Down 4. Very good. It's going to be Skylar again, I think. Hey, how'd I know? All right, so Skylar, what's the maximum point?
Is it -1?
Okay, so normally it would be 3, but you shifted down 4, so that's -1. All right, and what's the minimum point, Skylar? It's going to pick you anyway, so.
-4.
-7. Because remember, the amplitude is 3, so normally the minimum would be at -3, but then it shifted down another 4, so it would go down to -7. Does that make sense? Okay. All right. So, and then, so like if this were a test question or whatever, remember you can always graph it and see, like, okay, does it really go down to -7? 1, 2, 3, 4, 5, 6. Yeah, it does. So you can kind of check it, something like that. Okay, so any questions on any of those? Okay, so the last thing that I would like you to do is to fill out the unit circle. Now, believe it or not, this book, this calculus book, does not even have the unit circle in it. Okay, so what I want you to do is just start off and just see how much of it you can fill out on your own from your memory of trig. Okay, then what I want you to do is just Google it, unit circle. Okay, and then just check it yourself and see if you've got it right. Okay. So it doesn't, or yeah, you can, but I want the exact values here. So let's see if I've got, no, let's go back. Okay, so like just starting with the first quadrant. I'll kind of help you with that. So with the first quadrant, you want to label your angles in both degrees and radians. So 0 degrees is 0 radians. 30 degrees is pi6 radians. 45 degrees is pi4ths. 60 degrees is pi3rds. 90 degrees is pi12. Okay? And then as far as, when we do the coordinates of each point on the unit circle, see the x value will be the cosine and the y value will be the sine. Okay? So what we're going to do is, and it follows this pattern. The pattern is radical 0/2, radical 1/2, radical 2/2, radical 3/2, and radical 4/2. Well, so radical 0/2 simplifies to 0. Radical 1/2 simplifies to 1/2. These don't simplify. Radical 4/2 simplifies to just 1. And so starting with the cosine, it starts with 0, so that's the blue ones, and it goes down. The pattern follows this pattern going down. 0, 1/2, radical 2/2, radical 3/2, 1. The sine follows the same pattern going up. 0, 1/2, radical 2/2, radical 3/2, and then 1. And so that way, if it incorporates all the angles from the special triangles, the 30, 60, 90, and the 45, 45, 90. So then if you want, well, what's the sine of pi 6? Then you say, well, that's the y value, so it's 1/2. What's the cosine of 45 degrees? Well, that's the x value here, so it's radical 2/2. And then the rest of the unit circle, you use that awesome students take calculus to just figure out what the sign, positive or negative, is for each one. Okay? So I want you to try to fill it out and then check it on the internet. Okay? So anyone think they'll have problems with that?
No.
Okay. All right. So then my next quick question is what I would like to do is go ahead and have you take for tomorrow, take the quizzes. Well, let's just do 1-1 and 1-2. And then if you have a question on 1-3 on any of the formulas or whatever, then you can ask those. So let's not push 1-3. So you can look for those to be posted at the regular times that we agreed upon for tomorrow. Okay? And anyway, most of you are taking it tomorrow. Some of you are taking it Thursday. Okay? So we're gonna post the quizzes for 1-1 and 1-2 tomorrow. And then we'll also, if you have some questions on 1-3, then we'll go over that, any of the formulas, and then tomorrow we'll plan on starting in on 1.4. Okay? Oh, the other thing I was going to tell you about 1.4 is it's very calculator intensive. So make sure you bring your graphing calculator to class tomorrow, or you will feel a little bit lost. Okay? All right. Any questions, comments, concerns before we call it for today? All right. Thanks, you guys. We'll see you tomorrow.